All right. It appears... Why is it frozen? Okay. Sorry about that, guys. I was using Google Chrome instead of Firefox, and it tends to make my computer go wonko a little bit. So, anyway, we're back to this point where I've measured the methanol, and, well, since I've regenerated lab, it's new solutions, but still the basic principle here. So, methanol and the cube, I found that methanol was the only one where the cube dispersed the volume, so it sank. So the cube's density now is, you take 0.99 for my experiment divided by 0 is still going to be 0.99. If my computer will respond. Hello, computer. 0.99. There. Okay. And that's correct. Now, the next step, let's zoom out. It's not responding again. All right, let's just go to the next phase. We don't have to clean that up. And the question asks, review your observations, behavior of the cube in each liquid. Which liquids can you use to make your suspension mixture? So let's look. Remember, for this experiment, the only one that it sank in was methanol. The other two it floats in. So if we were to place it in the two liquids that floats, then it wouldn't give us the information about the density, because we're looking for a mixture in which it suspends. That means we've got some of the liquid on top, some of the liquid on the bottom. Okay, so anything where it's floating is not going to work. And anything where it's completely sinking is not going to work. So some combination that gets the box floating with solution around it. So knowing this, we can't have, so we can have methanol and glycol, an ethylene glycol, and we can have methanol and water. We cannot have ethylene glycol and water, because all it would do is just float on top of both of them. It would just keep floating. Okay. So we're going to have the same volume of methanol in the graduated cylinder, and we're going to adjust the volumes of the water. So 2 milliliters of methanol, and then 1 milliliter of deionized water. Get our stir rod, stir it. Okay, throw that away. Pick up our cube, and let's see what happens. And for this one, 2.00, make sure you use enough significant figures. 1.00 water, and it sinks. Okay, so we pick that up, pour it out, dispose of it. Next one. Again, 2 milliliters of methanol. 2, throw it away. And then now we're at 2 milliliters of water. Throw that away. Take our stir rod, stir it. Okay, and it sinks. Okay, empty it, dispose that. Next, again, 2 milliliters of methanol. Now, 3. Stir. And it sinks. 2 of methanol. Two, 3, 4 water. Stir. And it sinks again. Let's see. Okay, since that was a little repetitive, I just went ahead and did the other volumes. So the last volume again is 2.00, and then I added 6 milliliters of water, and this time it actually suspended. So as you can see, the cube is suspended in the liquid. Okay, so you've got a little liquid on top and a little liquid on bottom. Although it looks different there. But anyway, so it's suspended. So the mixture that it's suspended in was mixture 6. Now we need to calculate the cube density. So let's go to so remember this, since it's mixture 6, that's composed of 6 milliliters of water and 2 milliliters of methanol. So let's clear this. Well, I wish the whiteboard would clear. Let's see. Oh, I'm just going to have to... Alrighty. So we have 6 milliliters of water, and let's look at it again, and 2 milliliters of methanol. Okay, so since we have to figure out the mass, remember, density is equal to the mass, or grams, over milliliters. Okay? The density of water is 1 gram per milliliter. Let me just... So for water, it's 1 gram per milliliter. So if we have 6 milliliters times the density of water is 1 gram per 1 milliliter. Remember, our milliliters will cancel, and we are left with 6 grams of water. Right? Methanol, let's look back at, if we go down here, we can pull up the density of methanol. See, here's water, it's 1. Methanol is 0.7918 grams. 0.7918. Oops. So methanol we've got 2 milliliters times the density of what was that again? Methanol 0.7918. Okay. .7918 grams per 1 milliliter. Okay, so then our milliliters will cancel, and you are left with 1.5836 grams of methanol. Question is, though, what is the total weight? So let's take these values and add them. So it's 6.0 plus 1.5836, and you get 7.5836. All right, then the total volume, okay, this total volume is equal to 8. Okay, so this many grams over a total volume of 8 milliliters should give us the density of 94795. That's a 4. Okay, and I believe it's just 0.94. Let me get back here. Okay, close this out. So that is the density of the liquid, but remember the liquid is equal to the density of the cube because it's suspended. Okay, so it's actually 0.948 is the density, because we're at 3 significant digits because it was 0.00, so 3 significant digits of our for our density. Okay, so that's correct. All right, and there's our lab. Now remember, when you're done, you want to click up here to the print and go ahead and make sure it's saved to PDF and click save, whatever drive you want to put it in, just to make sure you've got that recorded on your end. Just to make sure that there is nothing wrong with your sign-in or whatnot. Each of them should be unique, so please do not try to copy or send between classmates. So anyway, they're unique to your student account, so just make sure that you have your own unique your own unique lab, and just save that, because I will pull up your lab grades from the lab directly. Okay, well, thank you very much, and I hope you guys are having a great evening. Thanks.